This is Analytical and Programming Center for Eco-Friendly Advanced Technologies. That's the full name. I know it's long, but it's the full name of this location, which conveys the whole idea of what we do, what we are going to do. So good luck and hope to see you later on.
And now it's time to start our seminar, and I will have a pleasure to give the first presentation. I am the representative of the researchers, of the science on this platform of meeting science with entrepreneurship that will take place today. So I would like to tell you a few words about research, how important research is and how much research is a basis for application that is later on implemented by the companies that you will also have a great pleasure to meet today. I would like to tell you a few words about alternative management of contaminated sites and what benefits for the environment, for agriculture and for industry can be reasoned from basic and applied research. And I would like to present you our scientific project that we have in frame of Horizon 2020, a European program held at the European level. So let's have a look first for a few facts. So more than 2 million hectares of areas in the European Union together with UK are polluted, significantly polluted due to military activities, industrial activities, mining, landfills, and all kinds of anthropogenic activity. I checked, it is the area about 2/3 of Poland, so the problem is quite significant. Moreover, about 2.8 million sites, due to the high pollution with organic and inorganic compounds, cannot be used for food and feed production. So there is a huge need to remediate the polluted sites using microorganisms in the process that is called bioremediation, or using plants in the process called phytoremediation, and the best is to combine the two partners together. And on the other side, to meet the requirements of sustainability in environment management, we need to use green biomass and bioproducts that will not contribute to increasing of pollution in the environment. So we need green biomass for bioenergy, for biomaterials, for biofibers, biochemicals, building materials, and so on and so on. You will learn more about it from the presentations later on. For bioenergy, I don't know if you realize that nowadays 5% of fuel that you use in your car has the prefix bio. So the biomass, the fuel produced from green biomass contributes to 5% of your fuel in your car. By 2030, it should be 14% in the biofuel. So we need to have this biomass to meet the requirements. And therefore, there is quite a challenge how to cope with the increased demand for the feedstock, and at the same time, we should not compete with the area that is with the food and feed production. What does it mean? If we need to use green biomass for instance, for biofuels or some biomaterials, we need to have area to cultivate them. How to take that area? The easiest is to go to the field, but then we decrease the area that is used for food or feed production. That is not good because the number of, that the population is still growing and the area of the soil is decreasing. So it is in fact not an option. So what is an option? We can cut off or burn woodlands. We can dry peat bores, or we can dry marshes. But then it will bring negative fingerprint, carbon fingerprint to the environment. Huge amount of carbon dioxide would be released to the environment, and it is also not what we want to have. So we need to use some areas that are not competitive for food production, like marginal lands, like contaminated lands, and try to find the solution for management of such areas. On the other side, since the pollution occupies such huge area, there is a need to do some kind of remediation of those areas. So, how to solve those problems? And here there is a huge field for research. And many scientists try to solve those problems. And we also took this challenge, and in our GOLD project, we try to find a bridge between phytoremediation that is based on the cultivation of energy crops on polluted lands with the increased need for feedstock for the biofuel production. And what are the main objectives of our project? So we would like to find the solution how to optimize the growth of energy crops in order to obtain the highest possible biomass, and also force the plants to accumulate the pollutants, the contaminants in the above ground parts. And also in the further step, we will work on technology how to use that polluted biomass to produce clean biofuel. And in this project, we have a consortium of 18 partners from Europe, from Asia, and also from North America. And UMCS is a leader of one of the tasks within Work Package 1, that is within this task, we try to optimize selected high-yielding lignocellulosic energy crops for phytoremediation purposes and biofuel production. To this point, we have 7 polluted sites, 5 in Europe and 2 in Asia, in China. Our polluted site that we deal with is located in Upper Silesia, the most polluted region in Poland. And within this project, we try to optimize the growth of energy plants. We have 3 crops to work with: hemp, miscanthus, and sorghum. You can see here on the photographs how huge biomass can be produced by those plants, because on the first and the second and the last drop, it is me to show how big, how high the plants can be. And in the middle, our PhD student, Carolina, who is as tall as me or as short as me, if you prefer. And the technique that we use to improve the growth of those plants is using biostimulants. We use protein hydrolysates, humic substances, and mycorrhiza applied separately or in combinations. And by definition, biostimulants should increase plant biomass. And we also hope that they could increase the uptake of pollutants, of metals from the soil, and increase its accumulation in the shoots. And then such a biomass will be further processed to produce clean biofuel. I would like to present you just a few results that can be applied and that are clearly in line with the topic of the meeting of today. So we have sorghum and hemp. These are 2 our species that are cultivated on the polluted site in Silesia. I must tell you that the field that we use for our experiment used to be used before we rented it for our research, used to be used for agriculture. So there was some crop growing there used as a food. But you must also know that we checked the pollution, the soil pollution of this experimental field. It is neighboring to the metalliferous waste deposit from zinc and lead ore mining. So we were suspicious that it may be some pollution on the fields around, and it appeared that the level of zinc, the concentration of zinc in the soil is above 8,000 milligrams per kilogram, while the permissible limit for soils used for agriculture is 300. In case of lead, the limit that is allowed in the soil used for agriculture is 100, and we have over 2,000 milligrams per kilogram. Also, cadmium and arsenic level is highly exceeded. So what does it mean? Yeah, so that soil normally we should conclude that should not be used for agriculture. And we were cultivated our crops there, and using biostimulants we could find that the best effect in biomass production was shown after application of fulvic humic acids. Using this biostimulant we could obtain over 20 tons of dry biomass of sorghum and close to 8 tons of dry biomass of hemp. And okay, as you probably expect, the biomass was accumulating some metals. And here there is a result of simple calculation. Taking into account the concentration in the tissues, metal concentration in the tissues, we calculated how much metal you can remove from 1 hectare using this crop of sorghum and hemp. So when we harvest sorghum from 1 hectare, we can remove close to 6 kilograms of zinc from the polluted soil, close to 100 gram of lead, pure lead, and close to half a kilogram of cadmium. Using hemp, we can remove from the soil almost 1.5 kilogram of zinc and 144 grams of lead. And is it good or is it not good? And the question arises what to do with the biomass that we harvest, and if such an approach is really bringing the solution to that polluted soil. And the question is not so evident. First of all, about soil contamination, that is something that is the most interesting for many people. Yes, it may work, but after decades. So it is not 1, 2, 3 years that we will cultivate our plants and the pollution will decrease. No, we need decades for it. But on the other side, it is quite interesting to replace the crops used for food production by other crops for industrial application. Why? Very briefly, I would like to show you something that is not published yet, but will be published soon. We did the research of the crops growing around on the fields, crops that are cultivated and then they are harvested and sold in the market as food. On that diagram, you can see red lines. It is the allowed limit of metal, of cadmium and lead concentration in some food products. And the gray bars is the concentration that we could find in the plants collected there. So you can see that the situation seems quite dramatic. Only white and red kale should be used for consumption. On all other products should be, in fact, withdrawn from the market. So replacing food production by other crops is very interesting. And the application of this biomass obtained in such fields can be used as feedstock for production of biofuel, fibers, textiles, oils, different biochemicals, biocomposites, biopolymers, building materials, and so on and so on. And you will hear about it later on during other presentations. And also, very interesting is to give farmers some opportunity to earn money, because they will ask us, okay, I am cultivating kale, I am cultivating wheat, and you tell me I should not do this. What can I do? And I need to have some income to support my family. So we need to find such a crop that can be also profitable for the farmers to cultivate in the field. And of course, establishing vegetation, establishing plants to any polluted region is very important because it is also decreasing the spreading of contaminants from the polluted site to the neighboring sites due to water and wind erosion. So there are just a few examples of benefits that can be obtained from our research. So let's try to do the research and let's cooperate with some companies to implement what we do, what we invent in the environment. Thank you for your attention. We will have no time for discussion now, so the general discussion and summarizing will be at the end of the seminar. And now I would like to invite the first speaker, the second in fact, Professor Jaco van Gronsveld. Please, the floor is yours. I will just help you. Okay. It works. Jaco, the floor is yours.
Thank you. So I am very grateful to have the opportunity to speak here a bit about, let's say, the biophytoremediation of organic pollutants. And why is it so important? Because I am already since many years convinced of the importance of collaboration between scientists and industries for obtaining interesting results. And I will show you results from a few sites where we were implementing this phytoremediation. I will give you a bit of scientific background, but I will limit it. People who are interested in the more scientific details behind these studies that I will present, they may contact me or ask me later on, and I can provide you scientific publications about it. Soil and groundwater pollution, that is something that is already known for quite a long time, and there are solutions for it, but these remediation techniques, they are quite expensive. Excavation, you can imagine when you have to excavate soil, it is quite labor intensive, and it will also take quite a lot of time. And what to do with polluted soil? You have to bring it to a dump site, and in fact it is simply bringing the problem from one place to another. And moreover, you should need clean soil to replace it, and that is not so much available. That is why we were thinking already since a few decades about using plants and their associated microorganisms to clean up polluted sites. Because nature is providing us plenty of tools. Microorganisms, already since the end of the 80s, there were studies on degradation of organic pollutants by bacteria, by fungi, and the use of plants. That is something that started in the 90s of the former century. And then we came to the idea, let's combine plants and microorganisms, because a plant is in fact much more than what you can see. A plant is a plant, but there are very important inhabitants of the plant, and that are, for instance, on the root, the mycorrhiza, but there are also a lot of bacteria, and not only outside the root, but also inside the plant. There are bacteria, there are fungi, and that is the case in the root, in the stems, and in the leaves. So you will ask probably then, why are all these bacteria and fungi there? Well, in fact, they act a bit like plant probiotics. I was putting there at the left side Yakult and Actimel. Probably some people were using it this morning, and it is told to us, and it is not simply a story, it is really true, that it is in fact improving our health, because you must realize that when you are standing on a balance, that in fact in your body of the weight that you can read on the balance, about 1.5 kilogram are in fact bacteria. So that is quite a lot. Bacteria are very small, and so 1.5 kilogram are bacteria. Plants also have plenty of bacteria and fungi around them and inside them, and as you can see on that photograph of that cutting, 2 cuttings of poplar, one is simply put in water without anything else, and the other one, there is a bacteria, a Pseudomonas putida, added, and you can see after 10 weeks quite a difference in growth. That is because these bacteria are stimulating plant growth. And these plant bacteria interactions or plant microbe interactions we can also exploit for remediation of polluted soils, of groundwater, of air in what is called phytoremediation. So by definition, phytoremediation is the use of plants and their associated microorganisms to remediate. You can clean up a site, or you can also let's say, immobilize the pollution on place. And what is important to know is that, in fact, bacteria, the microbes, are the most important players in the game. I will explain you. The bacteria, they are present in the root zone. There they can degrade pollutants, because bacteria are very flexible in choosing what they eat. You know, bacteria, they can degrade sugars, they can degrade all kinds of biomolecules, but there are many pollutants that in fact are quite similar to pollutants, organic pollutants, and so bacteria simply eat also these pollutants. And that is something that we can exploit. In case there are new pollutants, well, new, very different from what are natural organic molecules, bacteria, after some time, they find a way to cope with it, because these bacteria that can degrade these new molecules, they have an advantage in comparison with their competitors that cannot use these strange molecules as a food. And another problem that can be solved with these plant-associated bacteria is that volatile organic pollutants that can be pumped by a plant from the soil, from the groundwater, to the atmosphere, that these pollutants can be degraded on their way inside the plant, on their way to the atmosphere. So you can have quite a lot of advantages from it. And I will show you a few examples of it. Bacteria, when a plant is growing on a polluted site, bacteria, microbes can promote the growth of the plants. So plants often are growing less on a polluted soil. When there are these microbes, they are growing better. These bacteria and fungi can also mobilize the pollutants, make them more bioavailable, and in that way, so also easier to degrade. And of course, they can do the degradation in the root zone, but also inside the plant. So bacteria, in fact, do the major part of the remediation. What I just want to do here is make a comparison between phytoremediation and the more traditional, more classical remediation technologies. So in fact, you can, when there is a pollution in the groundwater, there are pump and treat used. There are pumps installed in the field, and these pumps are pumping up the polluted groundwater, and then you have a unit where the pollution is removed from that groundwater. Well, plants can do exactly the same, but they can play pump driven by solar energy. Plants are pumping or consuming, in fact, a lot of groundwater. And for a poplar tree, everybody knows poplar trees. Well, poplar trees, they can pump quite a lot of water. For, let's say, a poplar tree of about 5-6 meters high, it is about 260 liters per day. Each day, 260 liters. You can imagine how much it will be then for 1 hectare of poplar trees when they are planted in a normal way, like we do it in Europe and in the United States. Then it represents a pumping capacity of about 4.2 million liters per hectare in 6 months, because in wintertime, of course, they are not pumping. And so you can consider the whole system as a pump and treat unit. The poplar tree is pumping the water to the root zone, and in this root zone you have a lot of bacteria and fungi. They are degrading the pollution, so they are playing, in fact, the cleaning units, and the few molecules of pollutants that are going inside the plant, well, they can also be degraded by bacteria that use these pollutants as an energy source. I will show you very quickly a few examples. One is an example of a BTEX pollution plume on a site in Belgium, you can see, of a car factory. They had since many years leakage of BTEX to the groundwater, and you can see there is a nice pollution plume, and I will try this. Okay, so there is a nice pollution plume, but it is mainly under the buildings, and so they could not install a pump and treat system, and then when it is not possible to do it by traditional techniques, then people start to think, oh, probably the biologists can help us with some alternative. And so there we planted then 275 poplar trees, and I will show you the results. Why poplar trees? Probably very important is to mention that poplar trees can pump these huge volumes of groundwater, and poplar trees and also willows, they are phreatophytic. It's a word that almost nobody knows, but in simple terms, it means that they are always growing with their roots until the groundwater. If the groundwater is at 3 meters, the roots go to 3 meters. If the groundwater is at 7 meters, they go to 7 meters. So that is very important, because your pump and cleaning system will reach the depth of the groundwater where the pollutants are present. And here you can see the evolution. This is in the year 2000, 1 year after planting the poplar trees. This is 2003, this is 2006, and you see from 2006 on, in fact, there was no pollution anymore passing through that or under that screen that was created with these poplar trees. So that was a very nice result. The Ford people were very happy about it, but we did, of course, a lot of scientific research on it, basic scientific research on it. I will only show you one thing that is quite interesting. Here in 2003, you can see that the pollution is still under the poplar trees, and then it is very clear there are degraders present. The degraders are there, they eat the pollution, but in 2006 there is no BTEX anymore present, and also the degraders disappeared. No use anymore, because it costs energy to produce this degradation system, and when it is not needed anymore, the bacteria will just throw it away, you can call it. So the BTEX degradation capacity was present at that site. That is very important. When you have a polluted site, first check if there is degradation capacity present or not. There it was present. And it disappeared after the concentrations were decreasing below the detection limit. Another example at the same site with diesel oil. So they had to fill the cars, of course, before they were leaving the factory. And there was a leakage of one of the storage tanks. And the storage tanks are here. And you see there was a quite nice pollution plume created. In 2006, we planted, where possible, some poplar trees and willows. And here you can see the result comparison between 2004 and 2008. And in 2008, there is no pollution anymore going under the buildings. And the pollution plume shrinked quite a lot. Oops. Okay. And then we did a lot of basic research about it. I will just very quickly scroll over it. So we were checking if they could degrade. I will show you only this. This is interesting. This is a petri dish and with two holes. And in one hole, there was a drop of diesel added, and in the other, there was only water added. And then you can see when there is diesel added, the bacteria, they are growing very, very well because they can feed on that diesel oil. Of course, we used also HPLC techniques, and we were checking the plant growth promoting capacities of these bacteria. We were checking the evapotranspiration. There was not one volatile organic compound that was volatilized through the leaves. Everything was below background values, so that also worked quite well. Degradation potential was again present and was very active. And so some more details I can show you in a publication, but I will just mention it. We checked if the bacteria in the lab could do the degradation, and here you can see 100% is the initial concentration, and then after 10 days in a closed vessel, most of the diesel compounds reduced a lot in concentration. We also checked the genes, really the whole genome was sequenced. And so we could see that indeed these bacteria that were active in degradation, that they were equipped with the right degradation genes needed to degrade diesel. This is another case, and then I will stop. This is a case where no degradation potential was present. That also happens, and even quite often. It is about TCE. So no degradation potential present, and so there we planted also some poplar trees. We installed some drainage system in the root zone, and that allowed us to really apply, just pour in the holes of that drainage system a bacterial culture, a culture of bacteria that were able to degrade that TCE. But that bacteria we first had to make because there was no degradation possible there. Well, it was not present there. And so we decided to make a bacteria that could degrade that TCE. And how have we done it? We took a Pseudomonas putida that is living in the roots of these poplar trees that we planted there. And that bacteria, we made a crossing with a soil bacterium that is able to degrade TCE. So it is just a crossing, a conjugation, we call it in biology. And then the next day, well, I always tell to people to get their attention, you let them do some bacterial sex overnight, and the result of that sex you can already see the next day. You can select then these bacteria, these kits that are able to degrade the TCE. And in fact, what you have then is that root endophyte with the degradation genes included. And that is not a GMO, so it is perfectly possible to use it in the field because the gene transfer is done in natural way, by conjugation. And so that is not considered as a GMO. And so we applied that on the field, and you can see on the field before inoculation, there was quite an evapotranspiration of the TCE. So in fact, it was pumped from the groundwater to the atmosphere, and already 3 months after inoculation, you can see that in the non-inoculated trees, there was still the same amount of evapotranspiration, and in the inoculated ones, it was already 90% lower. So that worked very nicely. So no TCE or almost no TCE evapotranspiration anymore after that short time. So a few conclusions, and I can see that one disappeared from the screen. So I will have to tell it to you. You have two possibilities. Possibility one, that disappeared. Okay, it is there. Option one is that degradation capacity is present in the natural bacterial population, and then you can just stimulate it. And stimulating can be done often by planting more trees or more plants, because plants, they will create in their root zone an environment that allows 100 to 1,000 times more bacteria to survive there than let's say, in the soil only. And the degradation capacity sometimes is not present, and then you can inoculate and introduce the degradation potential. So, take-home message, phytoremediation of organics can be very successful. A complete cleanup is possible within a realistic time frame. Within 5 to maximum 10 years, you can get a good remediation, and phytotoxicity and evapotranspiration, they can be strongly reduced in case you use the combination of plant-associated microorganisms and the plants. Okay, thank you very much. I exceeded my time a little bit, but...
Thank you very much, Professor van Grunfeld. And now we'd like to pass the floor to Mr. Randy Mott from Phytoremedia Incorporated, our first company speaker.
My name's Randy Mott. I'm a lawyer. It's like being an alcoholic. Realizing you are one is one of the first steps to recovery. I've been in Poland for about 20 years. Before that, I was an environmental litigator in the U.S. for another 20 years. I've been involved in waste remediation for over 30 years. And several years ago, I was introduced to the concept of phytoremediation. And after working on cleanups of sometimes exceeding $100 million for one site, the idea that the plants could do the work sounded pretty good. So what I'm going to do is take some of that science and try to shift it into practical, where this stuff can work. The first thing I will say is remember the time frame, and 5 to 10 years generally is what we're talking about. So if somebody has contaminated property and they're urgently wanting to sell it, I've got a buyer. They'll buy it if we clean up all the cadmium and chrome and lead from the surface soil. And they're here right now. You're going to bring in bulldozers, you're going to scrape off the surface, spend a lot of money and a growing amount of money because it's got to go to a landfill, hazardous waste landfill, and increasingly they're going to have more requirements and more issues, and that's the only solution you've got. We call it dig and dump. So if you wait to the last minute in any commercial transaction or any financial planning, you will spend an incredibly larger amount of money. So what can you do? FIDO, the rule of thumb is about 10 or 20% less cost. It depends on all kinds of variables, but I think pretty fair statement is invariably it's going to be the least expensive thing, way you can clean up the property. But it requires planning, as I mentioned. I'm not going to go over the details here. I think you've seen some examples in a lot more technical way than I've summarized. So I'm going to try to get through to commercial applications. And maybe I'll be out of the camera. Can't do that. All right. There's a lot of unused land in Poland. Every village you go through has got an old factory, chain link fence, old brick factory, broken windows where the kids threw rocks. It used to be, now it might be in the center. It might be across the street from a shopping mall. It might be next to a housing area. It could be extremely valuable commercial property for development. Nobody will touch it because once you march in there, you got a cleanup bill. Solution for public office, if the public isn't, a public entity is involved, and there is some kind of nominal owner, come up with what I call funny money. There's a lot of that available from the National Environmental Fund, from different EU programs that we just saw described, and start a FIDO remediation project. And you know that 3 or 4 or 5 years out, you'll have a commercially valuable property, and the general rule is you will get way more than the FIDO remediation cost back in added real estate value. And there are actually companies in the US that were doing this to make money. They were organized to take up contaminated property and clean it up and flip it. So it's quite economically feasible with the right team. I think you saw from Jocko's presentation, it's a little more complicated than just saying, let's go plant some trees in this lot. There's a lot of work that has to be done to do it right, and I'm proud to say he's our chief technical advisor for our company. Plants that are operating now in anywhere in the EU, when they're closed, they have to be cleaned up. They have to meet cleanup standards when they're closed. If they didn't bother to get a background analysis, sometimes they have to go back to virtually background levels. So everybody, we have enormous number of plants in Poland that were privatized, bought from the old state-owned system, and are now owned by international companies. All those companies are operating plants they know have a shelf life. Somewhere back in the US, Munich, Japan, Seoul, somebody knows this is the general planning date, we're going to close that plant and we're going to build a new one. Or we're going to consolidate these 2 divisions in 10 years or whatever. Those people should be doing phytoremediation now to save the money. So there's a case where time can work in their favor. Landscaping, I've got a slide on it, but I'm not even going to go through slides. I think I'm just going to talk and try to get time for questions. Landscaping, metals are a primary element and the plants don't destroy it, and bacteria doesn't destroy it. As in our first example for the gold program, it's taken up and accumulates in the plants. And in order to really reduce the metals, you have to keep cutting the plants out and replanting every year a new crop. So it works for crops. But another thing that it can work for is if you own a building, an apartment building or office building, and it turns up that somebody missed that you have a bunch of lead and zinc on the surface, which is very, very typical in Silesia, for example. 4% of all the land in Silesia is above the metal limits. And you're not going to be digging up, you don't want to dig up all around the foundation of the building. you can simply put in a phytoremediation landscaping plan. Instead of the cute little azaleas, you get another cute little plant that Jocko can tell you what to use, and these plants will lock that metal in the topsoil. So A, it won't be airborne emissions, and B, it won't get into groundwater and go anywhere. Very, very sensible risk mitigation plan. Approved on some very huge, massive sites in the US. Sometimes there's so much heavy metal over such a large area, the only thing you can do is try to fix it in place and mitigate its movement off this to another receptor. If you're doing a risk assessment, you would look at different receptors for and pathways where the pollutant could get there. Small sites, organic pollution. Jocko gave you some big sites. Service stations are very common. Bigger sites. I think we have somebody from Ukraine listening in at their office. I'm trying to get more contacts in Ukraine because every one of those exploding fuel tanks that we see on films on the nightly news in Ukraine, that's an environmental site, and obviously there's going to be a priority to spend the money in better ways than moving dirt around. So the phytoremediation approach should be outstanding and perfect for all those oil and chemical tank explosions all over Ukraine. And the most economical way to do it, and it saves the people that are working on rebuilding money to spend on something else that creates more value. Rather than simply digging up contaminated dirt and moving it somewhere else. There's some jobs for truck drivers, but it's it's not going to be that great. And agricultural land, you just saw that example. Our problem there is a business model because the owner is the farmer, and we would provide the commercial service of coming in as a consultant and advising him on the plants and maybe monitoring it for a fee, and then that fee would have to be justified by the cost of the product produced. But I think basically it's safe to say now where you can use hemp, for example, in Poland, you make more money on a hectare of hemp than you do a hectare of cabbage. And I would much rather see that hemp going to fiber at Mercedes-Benz or BMW than see that cadmium and lead going into my cabbages or my carrots. So my new diet is I'm trying to eat a lot of carrots, and after that slide, I'm debating whether I find another alternative. I think we've covered all this earlier. Whoop, I went the wrong way. There's the service station, pretty short order, 3 years. Another important point to make is if somebody's buying the land and the Regional Environmental Inspectorate and the Marshal's Office have already approved a phytoremediation cleanup plan for that land, even if your plan is underway and not concluded yet, the risk to the buyer is reduced exponentially. Because normally a buyer comes in and says, it's contaminated, what's it going to cost? And their person doing due diligence will say, come up with the biggest number imaginable. Well, you're going to have to dig it all up and haul it to Vienna, Austria to be incinerated or something, or haul it to a hazardous waste landfill in western Poland. And that figure is massive, and that's the figure they use for their liability. If it's already under an approved cleanup order, their cost is the cleanup order. Their risk is that the cleanup wouldn't work. So a cleanup that's been underway for a year or two, that's showing results, and you're on one of Jocko's charts showing a decline, you should be fine. The risk to the buyer is greatly reduced. The value of the property goes up. And it's a magical thing. If you eliminate the contamination risk, the land value goes up. In some places that is critical. Some of these places are prime real estate and are not being developed in Poland or elsewhere in Europe because of the contamination financial risk. This is an example of cost. This one was done in lifts. I won't go into it. When the contamination is deep, too deep for the popular for whatever plant you're using, you can sometimes do it in lifts. So you do one season at one layer, then you clean out a half meter or a meter, and then you do another layer, and you can work your way down. And that was done in Canada. This is a famous site in Poland that nothing is happening with. The reason nothing is happening is right up here in the upper left, the cost. Cost freaked everybody out. This is lindane pesticide. It's toxic in water, chronically toxic at 1 part per billion. There are over 100,000 tons in that landfill. So multiply that by 1 billion, and that's how much it could contaminate. It is listed as one of the major threats to the Baltic Sea. If this lindane gets into the Wisła River, the U.S. I'm not right off the top of my head familiar with the European standard, but in the U.S., 1 part per billion lindane in the surface water renders the water unusable, non-potable, even with treatment. So what happens if the Wisła, we can't drink it? Imagine. So huge, huge risk. Essentially nothing happened for a long time because there was a legacy state company that still existed, and the owner pays doctrine was making it complicated to get public financing. That's been worked out by law, but there's still no program to clean it up. We've been there a couple times and think it would be ideal to put in a barrier of trees down here. The hot spot is 600 parts per billion of lindane all the way over here. There's another hot spot. There's another hot spot over here that's off the chart. The lindane is out of the barn. So the old idea of a few years ago that they're going to encapsulate this, that might be a good idea. It might be a good idea to dig part of it up, but it's already on the run. It's already leaving, okay? So the biggest risk is putting something down here. Even if you try to encapsulate it or cap it or dig it all up and put it back in a clay cell, landfill cell, you're still going to have a risk of it getting out. So you're going to have a big groundwater barrier anyway. So the trees down here would do the same thing as they did in Jaco's examples. And Jaco has found a bacteria that eats lindane. So amazing to me as a layman. Lindane's this big pesticide molecule, and there's a bacteria that finds somehow that parts of that are appetizing and breaks it down. So you can have a free pump and treat system by putting in the trees. They pump it out, and then they destroy the pesticide. The alternatives up there over on the left, just ridiculous. This one at top of my head, 4 million euro, 5 million euro for it'll be a permanent system. It'll have to be there, forever, and the poplar trees will naturally die at certain intervals and have to be replaced. The biggest ongoing cost will be sampling and analytical, to be doing the sampling to check for lindane. It's not a cheap lab test, but every remedy involves that cost. Every single thing you do at the site is going to involve that analytical lab cost. So we're hoping we can work with some government officials and get together a plan to stop this before it's too late. This is one of a dozen of these inherited from old state enterprises that just dumped everything out in the back. And as far as I know, virtually none of them are being effectively remediated. I will be a nasty, arrogant American and say the remediation efforts I've seen at some of these sites are pretty silly. This one had a little barrier wall down there where the local academic university that had no background in waste remediation put in some bark and stuff to try to filter the water, and it was there's no science behind it, and it was completely physically ineffective at catching anything. And the biggest concentration on the site is on the end of their barrier wall where the plume is going around the barrier. So this is serious stuff, and I think in 30 years I've seen it done right and seen it done poorly. This is some examples of landscaping. A firm that Jaco, I think, introduced phytoremediation and told the woman from Boston all about it, and she said, oh, this would be cool to use for landscaping. So these are examples of where an existing facility had contamination and planting was done to contain the contamination and reduce the risk for airborne or migration. Where it's not feasible, I mentioned last-minute cleanup. Heavy metals with an arbitrary deadline. I've got cadmium in here and I want it out in 2 years. It's not going to happen with plants. Groundwater deeper than 5 meters I think is problematic. But again, I showed you an example where it was done in lifts, where somebody did one period of time, they did the top and then they moved down. I don't know if you can sink poplar trees into a 2-meter hole, maybe, but you know, it's more problematic. Things that are easy, all kinds of organic contamination, because organic molecules break down, and any time that you have enough time. So I think I have a couple of minutes for questions. At the end, okay, all right. Oh, 2 minutes now? Okay, all right, well. I'll just say that I drive around Poland now, and I come to a beautiful facility like this. I stayed at a beautiful new hotel over by the Uni residence here in the city, and Lublin does not look anything like it looked when I was here 10 or 12 years ago the first time. Our whole country here is coming out to enormous heights, an enormous economic opportunity and development. But we're building it on sometimes a lot of real bad stuff under the ground. And we tend to want to ignore it. And the main reason the government ignores it is because of those huge costs. We've got about 10,000 contaminated sites in Poland. And the government doesn't know, are they all going to be 50 million euro a piece, or what is the deal? There's no main government fund dedicated to clean up the sites. Technically, the owner of the site is responsible for the pollution, and the person who put it there is responsible and remains responsible forever under EU and Polish law. But we're kind of all looking the other way because it's just too scary. The money's too big. Well, this approach is a way to deal with it to make it manageable, both for your city or your powiat or your company to say we've got something contaminated that we want to create more value for, we want to bring it into this thriving economy, but we can't do it because it's contaminated and everybody runs. And there is a solution to that. Not in every case, but where this is feasible, it's absolutely the best option you could have. Thanks.
So, Randy, Jaco, thank you very much for fantastic presentation and putting some light on the problems and the problem-solving possibility through phytoremediation. And now it's time for a short break, 20 minutes break. We invite you to take some coffee or tea and something sweet to wake up, to provide some sugar to our brain. And we are waiting for you in 20 minutes here for the second session, when we will really go to the implementation of what was showed now before in practice. Proszę Państwa, czas na przerwę, 20 minut. Zapraszamy tutaj za 20 minut z powrotem. Rozpoczniemy drugą sesję, gdzie poznamy praktyczne zastosowania innowacji ekologicznych. Zapraszam bardzo serdecznie. Najpierw na kawę, wzmocnijmy się trochę. Trochę cukru nie zaszkodzi.
Get
I
some
zapraszamy za
sugar
20
and
minut.
see
Dziękujemy
you in
bardzo
20 minutes.
prelegentom i dziękujemy
Thank you all
Państwu
speakers.
za udział w
Thank
tej
you
pierwszej
the
sesji.
audience for staying with us throughout the first session.
Kawa jest schodami w dół.
Take the steps down
Przypominam, żeby nie wynosić
to reach the
ewentualnie
coffee
słuchawek
and
z sali.
leave the headsets in the room, preferably, perhaps just where you're sitting.
Hello, welcome to the second sessions of the Eco Innovations for the Public Sector seminar. In this part, the first speaker will be Mr. Tomasz Małocha from Clean Bacter Incorporated. The floor is yours.
Dzień dobry Państwu, Tomasz Małocha i ja reprezentuję firmę Clean Bacter, czyli czystą bakterię, a więc jak sama nazwa firmy wskazuje, będziemy tutaj mówili o bakteriach. Cieszę się, że byli przede mną już przedmówcy, którzy wiele rzeczy z tematów bakterii podjęli, a więc nie będę się musiał powtarzać, natomiast ja powiem o takich rzeczach ze świata nauki, które my jako praktycy korzystamy. Także to będzie wyrywkowe rzeczy, które nam są przydatne do codziennego działania. Przede wszystkim chciałem powiedzieć, że nie tylko jest tutaj firma Clean Bacter, ale my jesteśmy grupą EcoPH. Jest to konsorcjum firm, a przede wszystkim zespół ludzi, dla których priorytetem jest dbałość i ochrona środowiska naturalnego. Dzięki współpracy i wspólnym wysiłkom tworzymy unikalne mikrobiologiczne produkty dla wielu sektorów gospodarczych. Tak? Ach, dobrze. Przepraszam. A więc tutaj jest jedna ważna rzecz zaakcentowana, że jesteśmy konsorcjum, jesteśmy otwarci na wszelkie pomysły, na wszelkie działanie z inwestorem, ze światem nauki. Dzięki tej współpracy tworzymy całkiem nowe produkty. Jesteśmy producentem unikalnych biologicznych środków. Gdzie te środki wykorzystujemy? Przede wszystkim do czyszczenia wszelkich zanieczyszczeń na danych powierzchniach. A więc możemy naszymi środkami myć podłogę, myć hale, czyścić w hotelu, w restauracji. Jest to bardzo wszechstronne zastosowanie codziennego użytku. Następnym obszarem jest utylizacja wszelkich pochodnych, znajdujących się we wszelkich rodzajach glebach, jak i cieczach. To jest bardzo ważny dział naszej działalności, że tak powiem, priorytetowy. Następnym obszarem jest
Yet another section deals with agriculture. We use our products to increase the quality of soil and humus. And then another section is eliminating unpleasant odors. We have oxygen and non-oxygenic bacteria, and those processes produce negative, unpleasant odors.
A więc stosując nasze bakterie,
using our bacteria, we produce situations for eliminating or reducing the unpleasant odors, which is vital, for instance, for neighbors of industrial plants or water plants,
I ostatni obszar to jest
waste treatment plants. And the final sector number 5 is creation of medical and cosmetic products. It's a very relatively fresh area for us. It's still ahead of its development, even though we have certain interesting findings, interesting developments right now, but we are growing in this field. Microbiology is our common denominator during this meeting, but I decided to write this and I talked with my business partners. Some basics are easily forgotten, so let me tell you what our philosophy is. We are working on solutions that are ready in nature. We are looking for what governs nature when nature is governed by certain laws or rules in an undisturbed, harmonious state. So this is what we mean ecology. That's the situation where environment works in a harmonious way without a need of external, extrinsic intervention. The basic rule that we work on is the rule of
mikroorganizmy, które
is the rule of
przerabiają
the
biomasę
circulation of matter in nature.
na to, co producenci, czyli rośliny,
So we have
przyjemnie wykorzystać.
we have this vision that inspires us, the circulation of matter in nature. We do not improve nature, we use its natural goods and resources. Microorganisms contained in our solutions have the GRAS status, the generally recognized as safe, so they are not genetically modified. These are cultures that can be met in nature, that exist naturally. We have a number of points. We have a number of points I made here for you to show you the distinctive features of our solutions and its uniqueness and competitive advantage. So the basic points to make is biosystem of oxygen self-supply. And our solutions, biosystem of oxygen self-supply, aerobes can function with a minimum amount of oxygen, with 0.3 milligram per liter. Thanks to our technologies, we are able to keep these organisms living. Our preparations contain up to 5 billion microorganisms per cubic centimeter. Durability. In tightly closed containers, our preparations retain their utilization properties for a year, and when opened, for yet another 6 months. Obviously, it's just what you can find as a label that we are able to guarantee. You know, operationally, they work longer, they are active for longer, but you know, to keep this safe, minimal, non-negotiable on our side. And range of activity, you know, it's like a blessing and a curse, because our solutions work on everything, basically. So on petroleum substances and their derivatives, we can the preparations work on types of hydrocarbons, regardless of their size, regardless of the chain structure. So this is obviously a lot of advantages, because we get better results implementing our innovative solutions as products, result in 3 times faster utilization. Obviously, microbiology realized from late 20th century recognized that it can be used in this particular way, and we are also using it. The use of our solutions leads to 3 times faster utilization of cleaning effects in comparison to biological agents. And because we work in consortia, the prices of our solutions can be far more attractive thanks to cooperation. A lot has been said by professors, by researchers on the microorganic world. Let me only tell me what is crucial for us as practitioners. So, work on bacterial consortia, which is Teruo Higa is considered to be the founding father of research in this domain. In fact, we can add that we do not follow his way of research, but obviously as a point of reference, as a person of reference, as a persona, is crucial, because our partners may recognize him as a crucial person. Quantum sensing is another phenomenon discussed by Nielsen and Hastings in 1977, and it says that bacteria communicate and calculate their numbers, relational numbers. When they reach a size of a particular kind, they move from passive to active status. If you compare it with parliamentary actions, when you want to vote over an act, You need to look consensus, you need to look a majority to vote. When you have it, you start an action and you vote over. The same happens with microorganic world. Micro beings communicate, and when they decide there are enough of them, they leave the passive state into the active state. I compared something I called old and new approach, but this is very, very pragmatic approach. You won't be able to find it in scientific discussions or debates. I realized that a traditional approach, that interest in fighting pathogens was prevalent. Until the end of the 20th century, interest in pathogens and methods of controlling them was predominant in research. And the pandemic and a lot of similar social situations, bacteria is considered socially as something bad, something that needs to be contained or reduced. However, the new approach sees the potential of bacteria, how to use this potential, because in the 21st centuries we realized the enormous and useful role of bacteria. And if we take into account how much or how important bacteria are to the human body, that they are necessary regulators of processes in our body, and they regulate all the processes in a given environment. That's the key role that we can utilize. Knowing this, having the background, the research background, we have developed a number of our achievements, and we would like to show them to you. They previously were considered impossible by biological methods like disposal of phenol, creosote. Science or research up until some moment suggested that the gas tar was not biologically disposable. We proved that it's possible, and we do this. We do have solutions to utilize gas tar as an off-product of gas combustion, and it has a lot of chemical compounds and substances. Just to mention some of them, what happens. We can see in the blue, you have the zero state, the concentration before the microorganisms were disposed, and the yellow one is when we applied our microbiological methods. You can see huge reduction in all substances measured. It's doable, as you can see, and it's the safest way of doing it. You can see natural oil and phenol, some mineral oil. You could see the beginning stage was 200,000 milligrams per kilogram. So that was a huge contamination. After 2 weeks, we were able to reduce it by, say, over 90%. So that's doable, as you can see it, in biological methods. But you need solutions, you need approach, and you need appropriate knowledge. Creosote utilization is another success of ours. It's an oil that is used to saturate wood, to have different use of timber in engineering and construction. And that gives a lot of protective value to wood, and also keeps its positive qualities in construction. But unfortunately, a lot of these substances have negative influence on health and environment. When the period of the use of this timber comes to an end, it needs to be utilized. up until some moment it was just it went to the combustion chamber with high temperature. Obviously, because of toxic content it had, regular combustion was not enough. It must have been high temperature combustion because a lot of substances evaporated. So that wasn't safe. So only high temperature combustion was the only solution for the time being. But we were able to prove that there are biological, microbiological solutions that you can apply. You can utilize creosote. You can utilize this. Use timber in microbiological method. And you can see the data. This experiment was here in Ecotech, held in Ecotech. In the center we are in here, and you can see only a number of substances analyzed, a lot of them actually is a problem in our case, but these three are perhaps a model to see. The blue one is again the 0 stage, concentration before our treatment, and then we have application of our microbiological solution. So we have the say orange or brown one after 2 weeks, and you can see the grey one after 3 weeks. Actually, you can't see it because it's so much reduced. And then the yellow one was after 4 weeks, but if you want to keep the proportion, then visually you cannot present it. But you can have a look at the data in the table below to see that actually we were able to reduce those negative substances, detrimental substances, by actually virtually 100%. Mostly creosote is a question of railroad support timber. They have a this is a very dangerous kind of substance. So basically we reduce it into the level of safe waste, and then we are able also to close the use of substance, because in fact this wood is reusable after our microbiological treatment. So basically this wood as biomass, for instance, could be used again without danger. The field we were also able to develop some solutions was agriculture, also cooperating with UMCS, with the university that is our host today, using our preparations, increase the weight of green beans by 70% and sugar beetroot by 40%. We also increased the degree of soil humus by 0.6%. This humus production, humus creation is crucial for keeping moisture in soil, and a small reduction in humus means that a lot of water is kept in soil, which is crucial, particularly in the context of weather anomalies we are facing at present. Green beans, as a case, you can see the control sample, only treated with water, and this is our control sample, so 100%. So we got 31.2 grams of growth. Now we used our preparation with 1 to 100 solution, and the third one was 2 to 100 solution, and you can see that there is a huge growth in the mass of produced beans, 53.7, which means over 70%, and this was after 32 days of cultivation. You can see that's a measurable achievement that is tangible, worth considering, and it shows effectiveness of our actions. A similar case with sugar beetroot. You can see similar approach with 100 and 200 solution and a huge growth of the plant. Now,
spotkanie z ośrodkami naukowymi i
talking with
jednostkami
researchers
administracyjnymi.
and local governments, that's this point I would like to share with you here. We realize that our consortia, our solutions can be used
o rośliny.
in the agricultural context because we do have particularly two strains of bacteria which are described scientifically as necessary, as important for the roots, where the roots are in contact with the soil. So we knew that, and we absolutely were sure that our microorganic solutions will help the plants grow. And the practice so far said that we should use the 1:100 solution, but in fact it turns out that increasing the solution by half or by 100%, it shows that the dosage should be larger. So, as far as and we need to change this application in our labels. Now, as far as local governments, something I would like to share with you, to be more open to innovation, to see them, so to streamline the formalities, absolutely realize how important documentation is, but some documentation creation should be faster. And then finally, for local government to realize that SMEs are highly innovative and it's worth supporting to get co-financing in solutions because SMEs are not able to reach for money for research that are extremely expensive. If you have questions, feel free to ask them in the general session. Thank you very much for your attention.
Dziękuję bardzo. Thank you very much.
Very much.
So now we'll ask the second speaker in this session, Mr. Marcel Nowosielski from C2C or C2C company.
Thank you very much. Ladies and gentlemen, thank you very much for inviting me here. I feel really grateful. And I would like to take advantage to introduce myself and our company. So, generally, I'm co-founder of C2C company, and currently I'm strategic director in our company. I'm sorry that I have to read some of my charts, but we have a time limit of 20 minutes, and I would like to fit in it. So, let's start here. So, the subject of our continuous research are innovative materials which can replace traditional plastics. And the content of my today presentation are four main points. First is the background, is introduction of our company, but not only. Then evolution of biodegradable packaging. Then we'll see some examples of currently implemented products. And then I would like to say something about future potential. So let's start here who we are. We are a team of specialists implementing real and useful material innovations in the field of packaging on the market. The subject of our continuous research are components and technology that will allow the production of foil-like materials in the least environmentally damaging way, which will be completely decomposed after the use without leaving any harmful residues. And because of the disintegration, it will create an added chain of values. I would like to say something now about the difference between traditional economy, which is linear economy, and circular economy, which is our future. So the linear economy is the traditional model that has been used since the very first day of Industrial Revolution. In this type of economy, the demand of raw materials is constantly increasing, as is the amount of waste from the products made from them. Despite increasingly new technologies for extracting raw materials and their better use, the planet's resources with this type of economy will be exhausted in the future. The circular economy is an economic model of the present and the future in which resources circulate in a closed loop. In this type of economy, generation of waste and need for non-renewable raw materials are minimized. The environmental impact is strongly reduced by using sustainable products designed in line with the circular economy strategies. Here we have the scheme of linear economy, and I would like to indicate that the use of the product is really short time. What we can do with the waste after use? There are only two ways. The first way is a traditional way. We can just throw it out to the landfill. Of course, everybody knows that it's not good for our environment. The second way, which is the only way which supports environment now, is incineration in professional waste incinerators. Thanks to incineration, we not only reduce the mass of the waste in the landfills, but also we get some extra benefits, such as electricity, hot water, and construction materials. So if we consider to use traditional model, the linear economy, the only way to come out from the mass of the waste is to use waste incinerations, which is all still not enough in Poland. We should create more waste incineration. But on the second hand, this is our proposal. We should rethink of what we are doing, and we should use circular economy. So where we are now and how our products are created. We start from the plant. Maybe I will use indicator. One moment. Could you help me? Pointer. Okay. So, basically, Okay. So we start here. We start from the plant. Then we need to do some easy processes, such as easy and environmental friendly processes, such as separation, extraction, fermentation, to get intermediate raw materials. Then we have a process of polymerization and industrial processing, and then we are in our company, which creates from the plants biopolymers. From biopolymers, we do extrusion processing. The injection processing belongs to other companies, but they are using our biopolymers. And this way we get eco products such as food packaging, bags, cutlery. I will show you the examples of products later. Then we have collection and disposal, and we get composting. So it's a biomass. We can also get biogas as a renewable energy. But mostly what we can do at home is to create from the waste just CO2 as an effect, water, and biomass. And here we have we can compare how works linear economy and how works circular economy, which we offer. So what companies and people are doing now to promote their business model? So I would like to give you an example of action in traditional linear economy. So, for example, in last 15 years, the thickness of single-use bags has been reduced from 20 to 6.5 micron. The idea was to reduce the mass of waste on the landfill. But at the same time, it provokes a lot of problem with recycling such bags. So we, as a company, we are not promoting this kind of model. And here is example of pro-ecological activity in circular economy. So this is totally opposite way. So we increased the thickness of the wall from 15 to 50 micron. Why? First of all, the product is multi-use. It's not a single-use product anymore. And second of all, the mass of this product is higher, and because of it, it's easy for collection, and it gives profits also for recyclers. And here, just to say a few words, that London University, as well as Danish Environmental Institute, they created this chart, and the information which comes out is that cotton bags are not so eco-friendly as everybody thinks. I don't want to say more about cotton bags now. I would just indicate that you need to use 393 times one cotton bags to have the same environmental impact as one plastic bag. But it's not about the plastic, so it was just a short message. And now, example number 2 of pro-ecological activity in the circular economy. The answer is biocompostable films. Biocompostable films are a product that, in the terms of functionality, does not differ from traditional polymer solutions. They provide excellent protection from the products packed in them. They can be used many times, but their advantage lies in the fact that they do not pose a threat to the environment after the useful life. Even if they end up in a landfill, they will completely decompose within a few months, leaving no harmful residues. And as you probably know, biodegradation is nature's recycling system. Now we are at the point 2, evolution of biodegradable packaging. I would like to show you a short video of our partner. This product was created together with the company Green Tree, is a Polish company. We are their partner, and we created a part of this packaging. But this video tells you more about the idea of compostable packaging.
This is Nature Biofilm, NBF. Let's print something on it using eco-friendly inks. Yummy. Now it's waste. But let's recycle it and give back to nature. The next steps are collecting bio-waste, composting and biodegradation. The process takes 45 days. The products of the process are water, CO2 and humus, a kind of soil organic matter, which is used to fertilization of agricultural fields. Growing plants take in carbon dioxide from the ground and air. Humus thrown onto the fields enriches the soil with microelements for subsequent crops. Thank you for your attention.
So now we have a background.
This is Nature Biofilm.
Of what biocompostable film is. And now a few words about evolution of biodegradable packaging. The evolution, or maybe better is to say revolution, started at the very beginning of 21st century. And because society understood that the waste on landfills are a serious problem and which can damage our life in the future. So a lot of companies, a lot of institutes started to search for a solution for traditional plastics. And the first solution was oxo-degradable plastics, which were traditional plastics that contained additives that accelerated the breakdown of the material into very small particles. Due to the use of these additives, the plastic breaks down over the time into the fine plastic particles, the properties of which are like those of microplastics, derived from the breakdown of traditional plastics. However, there are doubts about the biodegradation of plastic particles in uncontrolled condition in the open environment, in landfills, or in the marine environment. I would like to say that we are not big fans of this solution, and we were looking for something better and something definitely environmental friendly. And this way, we got into composting. Composting as a process requires that the material not only biodegrades, but also becomes part of a usable compost that provides nutrients to the soil. Available data suggests that oxo-degradable plastics are not suitable for any form of composting or anaerobic digestion and will not meet current EU standards for compostable plastics. Plastic particles remaining in the compost and potentially reduced microplastic particles may negatively affect its quality. Compostable packaging belongs to the group of biodegradable plastics that undergo biodecomposition in composting conditions in a relatively short time. The products compostable are marked under some standards of certification, where the most popular now is the standard EN 13432. So if you are interested in biocompostable packagings, you should look for this logo with the number EN 13432 on every product, on any single bag or on every single packaging. The packaging, biocompostable packaging, I mean, is made of natural and renewable substrates such as corn, potato, or even pineapple starch. Under ordinary environmental conditions, the material decomposes into its original form with the help of organic bacteria and returns to the soil. The cycle closes. That is why packaging intended for compost can be thrown into the bio-waste container. Composting is a process that takes place in specific conditions and time, and none of the substances remaining in the compost has a negative impact on the environment and does not pose any threat to the environment. Something about biocompostable film. So direct economic benefits from the implementation of packaging production. First of all is lower welding temperature. When the petroleum products need 200 degrees Celsius, biocompostable need just 120 degrees Celsius, which is energy saving solution. So we use less energy to weld those products and to create those products. Second of all, which is probably obvious, there is a lower carbon footprint, and it's lower approximately 65%. And now something about our products. So what is EFC foil bar C2C? The full name is Eco-Fully Compostable Foil. It is a flexible and thermoplastic composite material imitating various types of traditional plastics. However, unlike them, it's completely biodegradable in a short and programmable period of time. In its composition, it contains naturally occurring plant and mineral components, as well as acids of biological origin. The effects of material after use decomposition are only CO2, water, and humus enriching ecosystems. EFC foil are a wide range of biocompostable materials that will replace traditional foil packaging such as polypropylene and polyethylene films, films for soil mulching, protective films, sacks and pouches, checkout t-shirt bags, vegetable bags, plastic laminates, and many other single-use products. EFC foil has the same mechanical and functional properties as a traditional plastic, but thanks to innovative production processes and the use of natural substrates, we can freely shape the physical properties as well as their time and effect of the composition. I would like to say that we also produce biopolymers not only to create film, but also some imitations of hard plastics, and it is our answer to a worldwide demand for more sustainable plastic materials. First of all, I would like to say that we are not competing with the land for agriculture because we are using the plant waste after processing to create our products. All our products are GMO-free, and this is seriously sustainable material replacement. So, how we can define our film and our products? So our products are, first of all, bio-based, are biodegradable, and are compostable. And all these three factors are combined together into one product. I think I'm about to finish my time, so I try to speed up. So yes, here's the chart about the use of the lands for agriculture, for the food production. And as you see, that global land area is 13.4 billion of hectares, and global agricultural area is 5 billions. So from the global agricultural area, we can divide few areas. For us, the most important thing is the material use, where the bioplastic use of the land is less than 1%, 0.02% of the ground. And then some scientific information. So all our products needs to pass the standard test as a norm EN 13432. What does it mean? That means that the test is combined from 4 different tests. First is test of on biodegradation. So breakdown of material into CO2, water, and minerals need to take act in 6 months. But as you see, we can degrade fully our material in 8 weeks. The second test is the test on heavy metals content. And we can easily prove that using this test that our material contains no heavy metal after use. Test on disintegration, physical falling apart of the product in small fragments, then disappear totally. Test on ecotoxicity, it measures if the composed product does not exert any negative effects on plants. And as you can see, using our film with the blank compost, without growing the plant using just blank compost give us a smaller effect, smaller plants than if we add our material into the ground, which gives us the result in higher plants and stronger plants. And here is something about legislation, because this is the main barrier now for us to sell more products and to implement more on the market. There are some countries in European Union which already implemented the legislation, and it's Spain, France, Italy, Great Britain, Romania, and Hungary. The Greenlands, the lighter green are countries which are considering and should implement this law till the 2024. And time? Okay, so just to finish and reassume that I would like to say something about degradation, biodegradation, and compostation. The main thing to distinguish this product, to understand which product is which, is certification. So the most popular certification is TUV, TUV certification, and we can vary here industrial or home compost certification. All our products are home compost, which means that you can decompose the product in your home compost, in the compost near your home. Okay, I see I'm run out of the time. So just a few slides, what kind of products we can create for our film. So the most popular product now is mulch film for agricultures. This kind of film, we don't need to collect after use. We just leave it on the ground, and next year, this kind of film gives us real benefits in the higher plants. The second products are garbage bags for brown waste bins. So it means it is the stream of bio-waste, and it's better to use these kind of bags because we don't need to remove them on the compost companies. Then we have all types of bags, starting from shopping bags, then bakery bags, vegetable bags, etc. We have shrink film applications. We have imitations of paper as well. And we have also some freezer bags and freezer film. And our plant products, this is the future, this is what we're going to implement, is ecological food stretch cling film, biocompostable film with anti-static protection for electronics, biocompostable laminations, more laminations, and where else we can use our biopolymers. It is hygienical use, such as face masks and diapers. There are nets, all kind of nets, even nets for fishing. There are coffee and teacups, 3D printing filament, bottle and containers, and short lifespan items. Thank you for your attention. I really appreciate it.
Thank you very much, Mr. Marcin Nowosielski. And now for the last speaker in this session, Mr. Piotr Pietras from Green Lanes Group. The floor is yours.
Mogę prosić o pomoc w przełączeniu? Czy możemy podać na jedną stronę i na drugą? W jedną stronę i w drugą, dobra? Dzień dobry Państwu. Bardzo dziękuję za zaproszenie. Jest mi bardzo miło, że mogę być tutaj. Chciałem właśnie się zabrać w opowieść o roślinie, jaką jest konopia.
And I would like to talk about the power of hemp, the full power of using hemp to benefit the environment. I'm sorry, time a little bit of a technical problem. They have been in industrial use for a number of years. Okay, so where we are right now in the world, we can see strong climate destabilization, we can see excessive loss of forest and biodiversity. We often talk about it, or we try not to talk about it, but we certainly need to face it. We certainly need to develop technologies that are able to support processes of remediation, of regaining the ground, reduce destabilization. Everyone, even today, we can see how Italy, Greece, and the southern countries suffered from fires, and statistically, over 52 square kilometers disappears every year from annual forest. When we have a look at the market, the wood timber market, sustainable felling in Polish law is 5 cubic meter per hectare. But European standards introduce protection for green areas and woods that is going to reduce the felling in Poland from 40 million to 30 million cubic meters a year.
Tak podają Lasy Państwowe.
I teraz
mamy sytuację polityczną, która ograniczyła import tego surowca do Europy.
So we basically we have a situation, sanctions on Russia and Belarus on timber, and even in Poland there is huge demand because even 4 million cubic meters is on demand, satisfied demand. Now, as far as cultivation is concerned,
mówią o tym, że
and the UN
23% powierzchni globalnie ziemi
informs us that 23%
Robione na
of
roślinie
land
daje
is devoted to
82%
plant and vegetable
zapotrzebowania
food, and that translates onto
światowego na
82%
kalorie
of
dla
global
ludzkości.
calorie
Natomiast
consumptions by human
77%
kind,
uprawionej
77% of land is
daje
used
tylko
for meat and
18%. To są badania
dairy.
ONZ-u. Czyli
But
mamy
that
tendencję do
translates
tego,
onto
żeby
only
produkować żywność, którą
18%
karmimy
of calorie
zwierzęta,
intake.
które to potem
So
zwierzęta zjadamy.
we have a tendency to
Przetwarzamy od
develop
razu
agricultural
bezpośrednio
production
do produktów i jedzenia tego. Więc
animals
dzisiaj
and
jeszcze
then
nie są nałożone
translate
podatki na
onto
uprawy
say
mięsne,
ineffective
dlatego to
calorie
mięso jest
source.
w miarę
So
stosunkowo dobrych
taxation
cenach.
is relatively
Mięso na przykład
limited.
wegańskie
This is
jest
why
troszeczkę
getting
droższe,
food, getting
ale
meat is
trend
relatively
jest taki, że za
easier.
kilka
But the
lat,
trend
jak
is in a
ten
number of
ślad
years
węglowy
when
do
you
upraw
calculate the
zwierzęcych,
carbon
no to będziemy
footprint,
mieli mięso
we will
prawdopodobnie
have
droższe,
much more
znacząco droższe niż to
expensive
dzisiaj
meat,
jest.
and that will
Teraz,
complicate the whole
jak sobie popatrzyliśmy
picture.
na tę
Now, when
konopię,
we had a
moi
look
rodzice są
at,
rolnikami, wychowałem się na
at
wsi,
hemp,
od małego dziecka pracowałem w polu. To ta
My
konopia jest
parents
bardzo ciekawą
were
rośliną, ponieważ ma bardzo
farmers,
duży
and I
przyrost biomasy,
observed what they
składa się z
did
kilku
also
elementów.
with hemp.
Ma kwiaty,
It's a
takie
complex,
topy, które
it's a complex
mają właściwości nutraceutyczne. Robi się
plant.
z tego różnego
We
rodzaju
have stem,
suplementy
we have
diety
seed, we have
stosowane w
flowers,
medycynie.
and
Ilość
leaves
badań
used in a number
naukowych
of
w ostatnich latach na świecie
applications.
znacząco rośnie w tym obszarze.
So
Mamy
we can
nasiona,
see
które były
potential.
używane od
Okay,
zawsze
so seed
i główne
has been
przeznaczenie jest
used
na
for
tłoczenie oleju na
actually
zimno. To
from
jest
time
największy rynek
immemorial.
dzisiaj do
Obviously for
zagospodarowania
oils, for instance, for protein, meat and
jakby
bulk products.
światowo pod kątem
And
spożywczym.
perhaps
Natomiast białko
seed.
spożywcze jest bardzo bogate w coś takiego jak
And,
białko o nazwie
hemp
edystyna.
Hemp
Około
protein is
65%
rich
białka
in
konopnego składa się z edystyny. To jest białko
edestine, which
globularne,
is a
które jest
globular
najbardziej zbliżonym
protein,
białkiem do
very
białka
close
ludzkiego
to human
w organizmie.
protein.
Więc ma szereg
And
różnych
this is
ciekawych
why
prozdrowotnych
it has
właściwości.
a lot of
Ma bardzo wysoką
pro
strawialność na
health
poziomie około 97%.
features,
No i
like
można z
consumption
niego robić różne
level
ciekawe
of
rzeczy pod kątem
97%.
obróbki.
And it can be
I
used
ostatnia rzecz, która zostaje z tej konopi,
processed in a
to są
number of
łodygi,
ways. And finally,
których na polu zbiera się od około 10 do 15
stem,
ton z 1 hektara. Tak?
which can
Czyli
be
całkiem dużo.
biomass.
Konopie rosną do około
And it
7 metrów
produces,
wysokości,
if you
w
take into
zależności od
account
gleby.
the
No i
stem
dzisiaj
takes 7
w Polsce
meters,
przynajmniej bardzo
then you
często
can
ta
imagine
łodyga
how
stanowi
much
odpad
biomass can
produkcyjny.
be
Rolnicy
used.
nie mają co z tym zrobić,
At the
więc mają
time, for the time
problemy z
being,
przetworzeniem
farmers find
tego,
it
to
difficult to
zimuje.
process it, to use it. They just try
łodyga
to find any
rusza
way
je,
to
na
get rid
wiosnę
of
da
it.
się to przetworzyć, natomiast na jesieni jeszcze nie tego jest bardzo trudne. No i my pomyśleliśmy
Now, so
sobie,
we thought
że
that
trzeba popatrzeć na
we
to,
can think about how to
jakie mamy
use,
API, tak, czyli te zastosowania łodygi,
how
ziarna
to
i
employ all these
kwiatostanu.
three elements of
patrzeć
our
na to, jakie
plant
mamy rynki zbytu na to i
on
jakie mamy
particular
możliwości
markets, on
technologiczne,
particular
jakie możemy
technological
wytworzyć IP
solutions
nową
that we
wartość.
can produce
I w taki
new added
sposób
value
zdedukowaliśmy
to
sobie
the chain.
strategię,
So we
którą
developed
teraz
our
realizujemy
strategy
od 3
that we
lat.
are
Ja mam
following
przyjemność jakby
for 3
zarządzać
years,
wdrożeniem
and
całej
the
tej
director
strategii.
for the
I
strategy for its
stworzyliśmy
implementation.
3 biznesy.
So basically we have
Green
developed
Proteins,
3 business
Camping i The
lines.
True Green. A obok tego mamy taką spółkę agrotechniczną,
these
która
businesses
przerobiła
are
około 100 hektarów
geoproteins,
upraw i 9 odmian
hemp
konopi siewnych.
seed, and the
The True Green
True
zajmuje
Green,
się
as you
tworzeniem
can see, the
substytutów
logos.
drewna na bazie
True Green deals
infragmentowanej łodygi.
with,
Ja tutaj
with
puściłem
substitutes of
na
timber.
salę taką 2 deseczki konopne, więc można dotknąć, zobaczyć jak to wygląda.
You can touch it,
To ma
you have
właściwości
tangible
zbliżone do
experience.
drewna. To jest
You
drewno
know, it's
zbliżone
like
do
a
drewna
wood
twardego.
plank,
Da się to normalnie obrabiać na tradycyjnych
can be
maszynach.
traditionally
Zaraz
used
powiem dalej,
process
na jakim
on
jesteśmy
wood,
etapie.
wood
Natomiast
machines,
jakby
wood
to jest realny
processing
substytut, który może
plants.
zastąpić w
It's a
przyszłości
natural
sosnę,
substitute
dębinę
that can
czy buk.
substitute
Kolejny biznes,
other
który
wood
uruchomiliśmy w ramach
or timber
Green to jest Hempit,
varieties.
czyli pracowaliśmy z substytuty
Hempit,
mięsa na bazie uwolnionego białka konopnego. A żeby to białko pozyskiwać, to opracowaliśmy technologię w Green Proteins, gdzie kupujemy makuk konopny po tłoczeniu oleju,
we developed
stanowiący
particular
odpad
technologies to
który
handle
dzisiaj
that.
w głównej mierze służy jako pasza dla zwierząt. To jest największy sektor.
Technology
I
that makes
pracowaliśmy
it possible
technologię
to
izolacji
obtain
tego białka do formy
protein
koncentratu
isolate
izolatu. Czyli
at lower
jesteśmy w stanie
prices
stężać
and
białko
with
do około
exceptional
90%.
parameters with 90%.
Tak wygląda nasz biznes, jeżeli chodzi o różne zastosowania
This is
API
our business
i o synergię w ramach grupy.
those particular
Widzimy dużą
sectors,
przestrzeń w
but also
przyszłości do
synergy
tego, że
between
będziemy razem
three
budowali w ramach grupy
layers.
cały
we
cały
can see a
supply
lot
chain.
of space for
Każda z
the
naszych
whole
spółek
supply
wykorzystuje
chain
różny
in
element tej
all our
rośliny.
brands and
Tak?
all our
Czyli jedna spółka
companies.
wykorzystuje nasiona,
GeoProteins uses
wykorzystuje łódkę,
seed,
więc
other
jakby robimy
use
wszystko,
stems.
żeby jak
So we
najmniej tego
try to do our
odpadu
best to
pozostało na polu
reduce
i żeby
the
jak najbardziej
waste,
zmaksymalizować zyski
to
dla
maximize
rolników.
the profit for farmers.
Jeżeli chodzi o biznes Hempit, to jest uruchomiony na rynku,
As far as
sprzedajemy
Hempit,
wytwarzane
branch,
mięso konopne,
we,
oczywiście substytut mięsa.
sell
Tak?
the
Mamy kilka różnych
hemp
pozycji,
substitute
jest on
for
dostępny w wielu restauracjach w całej
It's
Polsce.
available in a
Na
number of
przykład nie wiem,
restaurants
w
in
Ordo, Tel
Poland.
Awiwie, w Gringo,
But
w Lublinie,
also,
w kilku restauracjach. Zachęcam do spróbowania. W październiku
truly,
wychodzi marka własna, a będziemy
invite you,
dostępni w
truly
sieciach detalicznych. Zaczynamy
inspire
od
to
Carrefoura, więc jakby tutaj też już ten
I would like
biznes będzie
to
launchowany.
somehow
Jeżeli chodzi o
promote
Green
tasting
Proteins, to
this,
właśnie 2 tygodnie temu skończyliśmy
this
modernizację
supplement.
zakładu produkcyjnego.
We have
Instalujemy ostatnie
modernized
maszyny do
our
uruchomienia
plant
takiej
to
produkcji
start
pełnoskalowej.
full-scale
Jest ona
production
tutaj na Lubelszczyźnie,
here in
niedaleko
Lublin region,
Jastkowa.
close to
Będzie
Jastrzębów.
produkowała około
It
4-5
will be able
ton
to
na jedną
produce
zmianę
4 and
miesięcznie
5
gotowego produktu.
produce
I jeżeli chodzi o
per
drewno,
month.
robimy je tutaj na
As far as
Lubelszczyźnie.
True Green, that is
Mamy
to say
centrum
wood
badawczo-rozwojowe w
processing, we
Turcji,
have
które
R&D
stworzyliśmy.
center here close
I
to Lublin.
podchodzimy teraz do budowy zakładu
we are
produkcyjnego.
developing,
Zakład będzie produkował około
a plant
10 tysięcy metrów sześciennych
for
gotowego wyrobu rocznie.
10,000
Będzie
square
znajdował się na Lubelszczyźnie,
cubic
ale
meter
bliżej
of our product.
Hrubeszowa. Tam lokalizujemy
Closer
zakład.
to Zamość, closer
Uruchomienie
to
takiego
Lubieszów,
zakładu planujemy
east of
na
Lublin.
2025
And we plan to launch it in
jakby
2025.
Czas przygotowania prac
need
modernizacyjnych,
to-
wyprodukowania tego sprzętu jest dość duży, więc
Obviously, it
to nie
takes
jest
time. It's
takie
not as
łatwe.
simple. You can imagine the whole process to plan and implement
Tak
in
wygląda
this
to w
industrial
praktyce, czyli
level.
jeżeli chodzi
So
o
that's practical
białko,
cases.
to mamy
These are
ziarno,
practical
to z tego
cases.
ziarna tłoczy
You can
olej,
see hemp
zostaje nam taki
proteins
makuch konopny
pressed
po wytłoczeniu oleju.
to
To
get
zależy, może
oil.
być rzepkowy,
You
może
get
być inny, prawda?
cap. You get
Potem
the
mielimy
remnant
sobie
of this. This
ten
is
makuch.
milled.
I z tego makucha izolujemy białko.
And
To
then
jest białko konopne,
you
które ma
get
zastosowanie
protein
w
isolation
spożywce.
that
Ono
is
dzisiaj nie idzie do
used
spożywki, bo jest bardzo nieatrakcyjne pod kątem
in
wyglądu.
food
Ma
industry.
jeszcze pozostałości tłuszczy, ma
It's
różnego
very
rodzaju
attractive for food industry because
inne
it
rzeczy,
also
więc trzeba
contains
izolować to białko.
grease.
Prawdopodobnie jesteśmy jedyną firmą na
And we
świecie,
are
której
able to
udało się do
isolate this
takiej linii
protein if you
pełnoskalowej
want to have
zrobić,
it
żeby
clear as
to nie
a
działało
clean as a
tylko w
protein.
laboratorium, tylko
So we are
już na
able to
dużych
use it not only
urządzeniach, nie wiem,
laboratory
typu
scale but
tanki
also
500-litrowe
in
i
for
tego typu
instance
rzeczy, tak?
500-liter tanks.
Przepraszam. Tutaj widzimy hempit. To jest
You can
forma
see
surowa
hemp
tego
so
mięsa.
this
Potem
raw
jesteśmy w stanie obrabiać to na
meat
różnego
that
rodzaju
we
rzeczy.
reprocess it into,
Kiełbaski,
for instance,
meatballsy,
burgers,
tego typu
meatballs,
rzeczy.
sausages.
No i tak wygląda deseczka konopna.
And you can see
Z
finally
produkcji będzie
this
wyjeżdżała belka,
lumber
która ma
or
2,5
timber.
metra długości,
plank
18
that
szerokości,
has
więc to nie jest
particular-
żadna płyta.
It's not.
To, co
It's
zrobiliśmy,
not
to opracowaliśmy technologię otwierania
we
tych
have this
łodyg. Te łodygi
technology
też są pokazane.
that is not
Czyli nie
that
oddzielamy
does not
włókna od
produce big
paździerza, tylko mamy technologię
planks, but we
otwierania
have
tego i
relatively
nanoszenia
small
dwuetapowego
ones.
kleju,
We
żeby
introduce
dobrze to
particular
zaklejać,
kind
ale
of
tego kleju
glues
nie ma dużo. My
that
stosujemy dzisiaj około
keep the
12%
particular
poziomu
stems
zaklejenia.
together.
Robimy to na
So
bazie
the
kleju
glue
białkowego,
is
czyli to
no
jest klej
more
roślinny,
than
bez
15 to
formaldehydowy.
20%.
Początkowo oczywiście tego
It's
kleju było nawet
plant
45%,
based
ale
glue.
optymalizowaliśmy tę
We
technologię przez
optimized our
długi czas i udało
produce
się
from
zejść do
40%
bardzo,
of glue
bardzo
to
niskiego
reach the
poziomu, przynajmniej według nas,
10%
co
of
znacząco
this plant
obniża
glue that also
koszty wytworzenia
reduces
produktu,
the cost
ponieważ
of product.
no, będziemy w stanie być konkurencyjni do tradycyjnego
And
drewna, czyli będziemy w stanie
that brings
sprzedawać
us
to
closer to competitive
firmom
advantage with
meblowym,
wood
wykończeniowym
produce.
taniej niż
Wood
tradycyjne
derived
drewno.
produce.
Tutaj kilka zdjęć. Robiliśmy
Just a
na przykład
couple of-
testy w firmie Paget Meble, która jest jednym z
Examples
największych
of autographs.
dostawców mebli na świecie.
These are our tests in
Dostarcza
Paget,
meble
one
na
of the
50 parę
largest
mebli, to jest
wood
gospodarni
producers, wood
Pagetu.
providers in Poland.
Tutaj już pokazany jest cały
And then
blat
we have
zrobiony
this
z
larger element, table
słomy
plank.
konopnej. To jeszcze nie jest zaolejowane, oczywiście to można
It's not
olejować,
in oil, you
uszlachetniać,
can oil
lakierować,
it, you can
robić
use
dowolne
any
rzeczy.
kind of
To też
varnish.
jakby było elementem dużych badań,
That
no
was
bo jest
also
dużo
research
kleju,
to a large
można było
extent.
potem ciężko
Obviously, the question
uszlachetnić,
is if you're
a
using
potem
the
to się
glue,
inaczej
are you
obrabia,
able to
także no,
use it in further
może nie widać,
processing?
ta deska jest
So you can
niepozorna,
see
ale
it, it
ilość
just
prac
looks like a
R&D, którą
plank, but in
wykonaliśmy, jest
fact a lot of research
naprawdę ogromna.
that needed to be
Tutaj prezentowaliśmy to na
devoted into
stanowisku
it.
Huawei'a. Huawei
Now,
poprosił nas o
Huawei
taki
asked us to
jakby
present
ekologiczne stoisko
an
dla
ecological stand for them.
taką ławeczkę.
So we produce
To
this
są
kind
ścinki
of bench,
słomy
this kind of
konopnej, z
stand
których
for
to
them.
zostało zrobione.
You
To
can see
przyklejamy,
the
żeby
straw,
pokazać, z
the
czego
hemp
jest tworzony ten
straw,
materiał.
just to show the material to the people
Tutaj
who
jest
are
ten
visiting
stolik
the stand. And you can
konopny,
see the
tak,
stand, you can see the
zrobiony.
bench.
Tak
People are
wygląda to
sitting
z
in.
bliska.
You can see our produce, our wood produce in the
Można
close-up.
to właśnie
Hemp wood,
widać,
if I may
zaokrąglać, obrabiać jak
You can
tradycyjne
produce
drewno
it
na
in a
tradycyjnych
traditional
maszynach.
way
Oczywiście
as you
jak
do
każde
it.
drewno,
Any
inaczej
kind
się
of
obrabia
wood,
sosnę, inaczej
obviously,
dębinę,
they
więc
have
tutaj też
different
tego materiału
technologies
trzeba
for
się nauczyć,
processing.
dobrać prędkości,
So
dobrać
you need
noże,
to choose
natomiast nie trzeba kupować innych
various
parków maszynowych, to jest robione
instruments,
na
but you do
tradycyjnych
not
parkach
change to
maszynowych.
your traditional
Tak wyglądał nasz w ogóle pierwszy blat, który
plant
zrobiliśmy.
equipment.
Nie jest jakiś
This is
spektakularny,
our
ale
first
pokazuje, z czego
plank
to
we
było
produced,
robione.
our
Tak?
first board we
Tutaj włożona
produced,
ta słoma
and you
konopna,
can see the
tutaj różne
straw that has
wybarwienia,
been used, different kind
przekroje.
of varnish.
Byliśmy na wystawie na Łódź Design
We
Festival,
produced,
mieliśmy
we
całą
we
wystawę
showed
na temat konopi.
our products
Pokazywaliśmy
at the
różne
Wood
zastosowania,
Festival,
też
Design
nie
Festival,
tylko
showing
nasze
different
produkty, ale braliśmy firmy z rynku,
uses.
zaprosiliśmy do tej
We
wystawy,
asked
robiliśmy
our
ją z
additional partners,
Husarska Studio.
stakeholders,
Jadwiga jest jedną
design
z założycielek tej
holders,
spółki, też Detrupling.
stakeholders to show how
Jadwiga jest topowym designerem
diverse
wzorniczym, jeżeli
uses
chodzi o
this
projektowanie.
material can have.
Ma zdobytych 5
So,
nagród jako jedyna Polka w Europie. Tak? Nie ma
Our
drugiej Polki.
cooperator,
Ona zajmuje się
one of
wzornictwem
our
przemysłowym.
designer showed
Jak porównamy
how
sobie to na
flexible the
przykład
material
konopie
can
do
be.
lasów,
Now, if you
to
compare
tak, nie musimy czekać 30
annual
czy
power
60
of
lat na to,
plants,
żeby ściąć tą roślinę. Co
we
roślina
don't
jest
have to
dostępna w
wait
ciągu
35 to
150
60
dni od
years like
zasiania
with a
ziarna do
forest
zbioru.
from
Absorbuje około 4 razy
from
więcej
early
CO2
start
do
to
siebie, tak?
getting to
Czyli
being ready
nawet
to
do
cut.
25
So
ton,
with hemp,
gdzie las
it's much
absorbuje
faster.
około
It's like
5-6
2 times a year that you can have.
W niektórych krajach w Europie
that you
można
can
je
have
zbierać
much
2 razy
more,
w ciągu jednego
material.
roku. No i
In some countries, at least, you can have it twice a
hektara
year.
można uzyskać
So 1
do
hectare
14
can
metrów
yield
sześciennych
up to
gotowego produktu.
26
Więc to nie jest mało, to więcej niż
produce.
wycinka jednego
If
hektara
you
lasu
compare
w
it
sposób
with, if you compare
zrównoważony.
it
Tak?
with wood,
5 metrów
it's
sześciennych
almost
versus
3 times
14
more.
metrów. Nie trzeba stawać w aukcjach,
And
surowiec
of
można
course, you don't have
kontraktować.
to.
My akurat mamy
You
zbudowany
can
łańcuch
get
dostaw
from
z
farmers. You don't have
IWiZ-em,
to
czyli to jest
be a
Instytut
part of
Najstarszy Konopny
tenders.
Polski w Polsce,
like,
działa w Poznaniu.
We
Z
have
nimi
a
współpracujemy w
hemp
zakresie tego, że
institute
oni
in
zbierają
Poznan,
materiał siewny, bo rozmnażają odmiany, a
and
my
we
odbieramy
cooperate with
łodygi
them.
od rolników, które są
They
odpadem
help
po
us.
produkcji.
They help us with supply chain.
Jeżeli ktoś będzie w najbliższym czasie w Wiedniu
If
albo
you
miałby ochotę
come
wybrać,
to
to
Vienna,
zapraszamy. Teraz mamy wystawę w
we will
Wiedniu,
have our
na
exhibition
Wienia
in
Design
Vienna,
Week, później
in
mamy w
Vienna
Londynie na
Design
Izoli,
Week,
później
and then
w Holandii na Dutch Design,
in London,
później w Seulu i w Mediolanie.
Holland or the
Ta
Netherlands,
wystawa
and
nasza
Seoul.
cieszy się taką
It's getting more and more
pod
popular
tym
all
kątem,
over
że
the
ten
world.
produkt jest bardzo
Because
ciekawy
the product
dla
is interesting for
designerów
potential
i
for
jesteśmy
designers
zapraszani na
and
różnego
potential
rodzaju
users,
wydarzenia.
and we are invited in
Przechodząc
more
do
and more
mięska
number of
konopnego, to tak wygląda
events.
gotowy
Now,
produkt. Tutaj mamy
food produce,
meatballsy,
meat.
tu
You can
mamy
have
burgera,
meatballs
to
and
są
burger,
produkty
which
realnie
are
wytworzone u
made
nas
of
w
hemp,
firmie.
produced in our companies, in our production lines.
Mamy też food trucka,
We
który
have
jeździ
food
po różnego
truck
rodzaju wydarzeniach.
that visits a
Open
number
Air
of
Festival, tego typu wydarzenia, także jeżeli
events
Państwo
like Open
spotkają,
Air
to
Music
zachęcam
Festival.
do
If you have a
spróbowania.
look, if you notice that,
Tutaj mamy
please
też mięso
feel free
takie
to taste
szarpane,
it. Feel invited to taste
ale
it.
taka
Different
wołowina,
kind
przepraszam,
of different kind
ta
of
wołowina. Tutaj mamy
meat
mięsko mielone.
produce that resembles very
No i
much
teraz,
the
jak popatrzymy sobie, ile z tej jednej rośliny
meat.
można zrobić rzeczy,
So
to
now when you
myślę,
have a
że
look at hemp and
można
how many things you can do
zrobić
out
wiele
of
rzeczy w
one
sposób
plant,
zrównoważony,
you
bez
can
wycinania
see
lasów,
how much you can
bez
do in a
stosowania
sustainable
dużej
way
ilości
without
wody do hodowli
felling
zwierząt, do produkcji
wood,
pasz, tego
without
typu rzeczy. Tak?
having intensive
Uważam, że konopia
or
świetnie
extensive
wpisuje się w cele
agriculture, and I
zrównoważonego
think
rozwoju,
hemp
tak?
is an ideal
Badamy też kolejne rośliny,
plant
kolejną roślinę
for
roślin, nad którą my teraz pracujemy bardzo mocno i widzimy w niej duży potencjał.
development of the
Że
world.
da się wrócić do takich
I believe
korzeni,
we can
bo
be back to the
historycznie,
roots,
na przykład
to
w XVI
environmental
czy
roots,
XV
like
wieku konopie w
16th,
Anglii
century, where,
u
for
wszystkich
instance, in
rolników, którzy
England,
mieli ziemię,
hemp
były wymagane do uprawy. Każdy
was
rolnik
as
musiał mieć jakiś
expected
procent
by,
powierzchni, którą
by
uprawiał
rulers.
i oddawał
So
konopie
every
na cele
farmer
przemysłu,
was
rozwoju
expected
przemysłu
to cover
w
some of
Anglii,
his
tak? robiło się z, nie wiem, z tego
hectares
różnego
oil ridge
rodzaju
with hemp
liny dla
because
koni i
it
tak
was
dalej.
used
Moja
in
babcia
a number of
też uważa, że kiedyś każdy
uses.
miał konopie
My
przydomowych w
grandparent
ogródkach,
also
bo robiło się
confirms that
swetry,
everyone
linę dla konia,
needed to have
skarpety na
hemp
zimę,
in a number
dodawało
of
się z
applications
nasion
in the
cumpel,
village
tłoczyło się olej.
with
Także
fibers or with
prawdopodobnie
seeds, with oils and so on.
wrócimy do tego, co było kiedyś
Perhaps we are moving back to
w
our
przyszłości
roots.
i będziemy stosowali konopie
And we are going
do
to
codziennych
use
zastosowań.
hemp in everyday life
Dziękuję
in a
Państwu.
sustainable
Jak
way.
są jakieś pytania, to
Thank you very
pewnie
much.
w
I'm ready
kuluarach
to
mogę
answer the
odpowiedzieć.
questions.
Dziękuję i miłego dnia.
And have a good day. Thank you very much.
Dziękuję bardzo.
Thank you very much.
Ladies and gentlemen, it was our last presentation during this session. I would like to thank very much to all our speakers. We touched really many important problems during this meeting. Now it's time to do some short summary and open the discussion. So if you don't mind, I will start with some short summary, but please feel free to join me and please show or tell what was really touching to you. It's also time for the discussion. If you want to have any questions to our speakers, it's good time. Don't be stressed about language because we will help you. We have a support so you can ask questions in whatever Christian language you want and we'll manage to find answer to those questions. Można, proszę Państwa, zadawać pytania po polsku albo po angielsku.
You can ask your questions in Polish and English. We will help to render them in
te
a
pytania
particular
zadać i żeby
direction.
uzyskać odpowiedzi.
So to get the answers.
If you prefer the personal contacts to our speakers, in a moment it will be such an opportunity. We can have again some tea or coffee and sit or stand together downstairs and ask questions or find some solutions to make contacts. So the most important thing that I would like to say to summarize the meeting is that we didn't want to solve any environmental problems today. We wanted to maintain a platform to meet science, to meet research, to meet entrepreneurships and also authorities who are responsible for some environmental problems. So we wanted to make a platform to put all those people together because this is the only solution to solve environmental problems. First, you need to define what is the problem. Then you need to find a solution for this problem. And here, the big floor for the science, for research. We had several examples how much research, basic and applied research is important. And furthermore, that research should be then implemented. We had fascinating examples how the research can be implemented to solve environmental problems. And that implementation was connected with decontamination or cleaning the environment. But also you can apply it in our home, like cleaning products based on microorganisms, so natural cleaning products. You can apply it in the restaurant, in some plants, in some factories, and go further to the environment to clean up something that should be cleaned up. We could also see that without that, even in the moment in the stage of implementation, there is still very important to have the cooperation with science because we had an examples. So there was already a good recipe how to apply a product, but it appeared that we can really modify the concentration used, and it is even better for the environment and for the purpose of using that product. So the cooperation between researchers, between universities, research institutions, and companies that are implementing those solutions is really, really crucial. We would also like to thank all organizations and institutions and local authorities who have to deal with environmental problems. Because it is first you who need to deal with those problems. And we would like to tell that both research, both universities, research institutes, and the companies are very much open for the cooperation. And as it was also stressed during the presentation, we would also welcome you to be open for this cooperation with us, to be maybe, yeah, I know it is difficult, but all the procedures to implement some solutions sometimes are very long, very difficult, very complicated. So when you have a problem with the environment, we can find a solution and implement it. So please remember about it, and please remember that we are the platform to solve those problems. Also, something that was mentioned here is, politics. It is not a good moment to tell about politics now, but maybe it should be stressed that when we involve some politics, not only authorities, then sometimes it would be easier to solve some environmental problems. But please let me not continue about politics and this topic. Just remember that politics are also important, can be important partners in this cooperation. And finally, last but not least, what is extremely important, what rises from the meeting today, is education. So we cannot implement anything important for the environment when we are not aware of the problem and of the possible solutions. That's why it is extremely important to teach our kids already in the primary schools how to segregate garbage, because we could see how important it is to leave the linear economy and to move to circular economy. We can use absolutely everything without creating landfills of piles of wastes. I don't know if you are aware that every year we are consuming plastic. That plastic, microplastic, is present everywhere. And every year we are consuming about the amount that is like the card that we use for banks. So that is everything ending up in our stomach. How can we help it? Let's use biodegradable plastic. We cannot call it plastic, but biodegradable materials. That is alternative, that is fantastic alternative. So let's teach our kids already from the kindergarten to segregate garbage. So let's reuse it, let's retake it again, and let's produce something that can be really useful for us and very good for the environment. And the education should start from the very beginning, but should not stop there. University has a mission to educate people as well, and people who will deal with environmental problems. So going ahead and to this challenge, we are opening a new program, Maria Curie-Skłodowska University, in cooperation with other universities in Lublin, with Life Science University and Technical University in Lublin. We are opening together a new program for students, sustainability management. We are opening it now, and we will create leaders and people who are really aware how to define, how to recognize, and how to manage, how to deal with environmental problems. And we will teach theory, but also we want to go to the environment, to the companies, to show that it works. And that's why I think that it is so important to put people together, because we can really create very nice contacts for also education. And what I would like to stress, thank you very much for raising so many environmental problems, from pollution to some destabilization of the climate, fires and floods and so on. That is all, in fact, some result of our anthropogenic activity. So let's now move to what is proposed at the global level and is called sustainable development goals. That is something that was shown during last presentation and by Organization of United Unions. Also in Europe we have so-called European Green Deal. Thank you for mentioning it. It is very important policy. And also all local authorities have a mission to implement those regulations in the plans for development, for managing with the environment. That is very important, and we could see that it works, that simply we can do it. So I would like to thank very much all our speakers for the wonderful and inspiring and fantastic presentations. Thank you very much. It was a huge variety of topics, but that is so fantastic. So I was really amazed, and I was listening to all presentations almost with open mouth. So thank you very much for that. I would like to thank the City Hall, the municipality of City of Lublin, because without cooperation of our university and the city, we could not organize this meeting. So we don't have many members of the city of the City Hall here, but Marcin, please accept and please give our great thanks to the representative, to the city authorities. And I would also like to thank again our sponsors. Thanks to them, we can have the transmission online on the internet, and we can have simultaneous translation. Big thanks to our professors from our university who took that difficult task for me. It seems quite difficult and challenging. I think it is. Thank you very much. And thank you, our sponsors, for this cabin for simultaneous translation, because thanks to it, we all can participate and understand what is going on. And I don't know if I forgot anything.
Are there any questions, comments from the audience? I will gladly pass on the microphone. Czy są jakieś pytania albo komentarze z publiczności?
Are there any questions from comments? Please use the microphone.
And if you have some personal question, please tell, and then we will pass the microphone.
Leszek Sapsyl, Regionalna Dyrekcja Ochrony Środowiska w Lublinie. Ja mam pytanie odnośnie przybliżenia technologii oczyszczania podkładów tych kolejowych
of these sleepers, railway sleepers. Can you share more details with us? Whereas for us this decontamination of sleepers is a relatively simple method. We take this piece of timber, is cut into pieces, and then it's submerged into microorganic elements. Aeration comes, and this process takes time. It just works. They work. In this solution that we produce, the timber is not a waste. We do not produce waste, we reproduce wood. So after it can be used as a biomass. It can be used in other areas. You can see 4 weeks. It takes the whole process to complete in 4 weeks. Obviously, you have to keep the temperature and the conditions for the process to take place. Microorganisms work in a particular conditions. Certainly, yes, there are certain elements that you need to keep in, but by default, by principle, it's relatively simple.
It looks so simple, but in fact it isn't.
Any more questions? Okay.
Dzień dobry. Ja nazywam się Łukasz Wiechatek, ja reprezentuję
Good
Wydział
afternoon.
Ekonomiczny.
I represent
Także
the
z
economic
zaciekawieniem słuchałem
department of the city of
szczególnie
Lublin.
tutaj pana
I was
Piotra,
particularly
tego
interested in the last presentation.
Ja chciałem
I
pogratulować,
would
bo
like
pan
to
jest
say
takim
congratulations
storytellerem,
because
to absolutnie
the business that you
pan wie, co
have
pan robi,
developed
pan umie to
is
sprzedać.
wonderful and you're a
Pan też tak
wonderful
podsumował
storyteller.
te wszystkie
And
wystąpienia,
the
które
sum
tu były.
ups
Ja
that
mam
you
takie
gave
pytanie.
to all the presentations
Jak ta
before you. My
konopia
question is, how hemp
radzi sobie, czy w ogóle
manages, how hemp
radzi sobie na
survives
terenach zanieczyszczonych,
in those
bo
contaminated
można by
areas?
jeszcze połączyć
Perhaps
nasze
you can
wcześniejsze
have a
wystąpienie, że mamy
merger
taką
between
kultywację,
the
tak?
recultivation
Również z tych
remediation by
odpadów
means of
takiej
hemp
folii
and then use
biodegradowanej
it
robimy
to
nawóz, z tego mamy
biodegradable
konopię i później już wszystko
solutions
z tej
and so
konopy,
on.
co tylko
Okay, so
można.
basically
Były
hemp
takie badania,
is the beginning and end of a certain process, of a certain
to,
chain. Do you have
jak
this
taki
kind of
mogę sobie
research?
w taki gorszy warunek
How
radzić?
hemp
Jasne.
manages
Konopia co
in
do samego
contaminated
wzrostu
areas?
potrzebuje odpowiedniego pH
Hemp
gleby i
needs
w pierwszym
particular
okresie
pH
potrzebuje
of
odpowiedniej
soil
wilgoci.
and
I
develops
ona w pewnym
and it
momencie
needs
wzrostu przeskakuje
humidity.
bardzo szybko chwast,
So
około
at some stage
10 centymetrów
it
dziennie
grows very, very
rośnie,
fast,
więc
10
jakby
centimeters
przeskakuje ponad chwasty,
per day.
jakby,
So it happens
te
to
chwasty są
overgrow
zapuszczone
weed
i konopia rośnie.
and
I my co do zasady nie
and
robiliśmy
the hemp
takich
goes.
badań
So no, we
fitoremediacji,
didn't do
natomiast
research
robi to
in
INGiS,
phyto
czyli Instytut
remediation,
Nasiennictwa w
but
Poznaniu.
Poznan
Wiemy, że czysto jakieś
Institute
tereny
do
pod
do
Łodzią
that. They
i robią
use some
badania,
plant
które
in
potem będą
vicinity of the city of
opublikowane z ich strony,
Łódź.
natomiast no, ta
They are going
konopia
to
właśnie
publish
z gleby
something, but the
wyciąga.
hemp
Co
is
jest
used
zaletą i
for
wadą, no bo
decontamination.
że
Obviously,
gleba była
it's
wcześniej
a plus
bardzo
and minus
wyczyszczona,
at the
to
same time,
później, no,
because obviously,
badania
can you use this hemp
pestycydy, metale
for
ciężkie i tego typu
food
rzeczy,
produce? No,
więc, no,
certainly
ona
not.
chłonie
So obviously,
i w pierwszym
you have to
okresie
be
jest
careful
dużą,
about
wadą, później
about
jest to nasze
reprocessing it
zdrowie,
at some stage.
Mogę przekazać kontakt do
I can
Instytutu do
give
pana
you
Witolda Czeszaka, który odpowiada za ten
contact
projekt
with the
badawczy.
institute I have in mind,
Prosił porozmawiać z
so
nami,
you can
takich
talk
badań
to
nie
them.
robiliśmy.
We are not having this kind of research on our own.
If I can add just a few words, maybe it is a good moment to start some cooperation eventually to check if we can valorize our biomass from our polluted field. But what I wanted to tell you, there was a lot of research about using the biomass, the stems of hemp, that was cultivated on the polluted soil. And what we can say, Professor van Gronsveld was the leader of a project in Belgium using hemp. I just tell one thing that was the most striking for me, and I will let Professor continue. What they checked, they obtained fibers from the hemp that was cultivated on the heavily polluted soil. And what I will tell you, what is the metal content in the fibers that can be used like to produce all kind of textiles? It is much lower than in the t-shirts and the clothes that we are wearing. So the metals are excluded from the fibers, even if the hemp is growing on the polluted soil. And when we use dyes to make the textile, the fiber, colorful, there is more metals in the dyes than on the fiber itself, even if it is obtained from the cultivation on very polluted soil. Am I correct?
Yes,
Professor
yes,
van
yes, for
Gronsveld?
sure. That is correct. But I wanted to add something about how plants can survive, how hemp can survive on polluted sites. Well, that is again thanks to adaptation in their microbiome. So it is again a very important role for the microorganisms. They adapt to the conditions and they help then, in fact, the hemp and also other plant species to survive under such stressful conditions. On metal polluted soils, it are bacteria adapted to these metal contents, and on organic pollutions, well, they are adapted to, for instance, degrade the organic pollutants in the root zone, and that is why they are not taken up anymore by the plant. We have big experiments at this moment in Belgium on PFAS contaminated soils. Probably you heard about it. Near Antwerp there was a factory of 3M that was producing quite a lot of pollution during the last decades. PFAS pollution spread over square kilometers. And so there also hemp can be grown in a very nice way by farmers. There are quite a lot of farmers involved in that project. They grow hemp on PFAS polluted soil, and that hemp is perfectly usable for all kinds of applications that we heard in the last presentation. Of course, I would not recommend to go then to food applications, but all more, let's say, industrial applications, they are perfectly possible. The level of pollutants in the biomass is extremely low, below detection limits mostly. So, in fact, a lot of these soils can be valorized for growing hemp and other plants.
Questions, comments? Pytania jeszcze? So, if I may add, as the representative of the City Hall, this was a great privilege for us to cooperate with the Faculty of Biology and Biotechnology at UMCS. This event is part of implementing our strategy of bringing the various stakeholders of the city together, the business community, the academic community, local government, institutions, and society at large. I personally can notice various connections between the gentlemen and ladies presented today to further increase their innovativeness, and we hope that this event will be first in a cycle where we'll be presenting many more solutions in the future for improving our local community, and which can be scaled through our partner cities and partner organizations to the world at large. So if I may just add for the formalities, this event was under the honorary patronage of the Mayor of Lublin, Dr. Krzysztof Żuk, the Rector of the Marie Curie Skłodowska University, Mr. Professor Dąbrowski, and the sponsorship and great support of Bank Gospodarstwa Krajowego, represented by Ms. Izabela Przewłocka.
Thank you very much. And we are coming to the end of the official part of the meeting, but please remember, we still have time. We will not close a complex building in half an hour or 15 minutes. Please feel free to meet, to talk, to establish new contacts. If you have some ideas later on, not today, that you would maybe be interested in a contact to a person who was participating in the meeting today, giving the presentation, please remember that, and you don't have the contact to that person. We wanted to establish a platform for contact, so you may always contact us, organizers of this event, and we will provide you very happily the contact to the person of interest. So even if now you don't have questions, but later on it may be interesting to contact somebody, please feel free to contact us, and we will enable you the contacts to anybody that you would be interested in. And I was told to not tell it, but I have to. Directly from my heart, I would like to thank you, my friend and colleague, Dean of the Faculty of Biology and Biotechnology, Professor Joanna Czarnecka, for her help to organize this meeting, because Asha, without you, we would be sitting probably and crying. It was quite a challenge, but I think it worked, and it is in a big part thanks to you and thanks to your hard work. Thank you very much. So let's continue in private with coffee, tea, water. There is a place to sit, there is a place to talk. Thank you very much for your presence here in the auditorium, but also online in front of the computers. So if you have any further questions or any wishes that we can fulfill, please feel free to contact us and we will do our best. Thank you, and I hope see you in some similar event maybe in the future. Thank you.
Thank you very much. Dziękujemy.
Przepraszam bardzo, sytuacja wyjątkowa. Nie mogłem pani wystawić. Tak, oczywiście.